What's up guys, welcome to my channel. In this video I'm going to tell you about acceleration. So if you want to know about that, make sure to stay tuned. Okay, so let's start with the basic meaning of acceleration. So acceleration is the change of velocity with time. For example, assume a car moving at a certain velocity, and if it's speeds up, that means it has accelerated. And the opposite of acceleration is deceleration. This tells you that the acceleration is negative. But we'll do that now. So the acceleration symbol is this, a arrow, and acceleration's SI unit is meter per second square, because it has the second that the velocity has changed, so it's become second square. So in my video I did before, we talked about speed and velocity, which has an SI unit of meter per second. But this is acceleration, so it's meter per second square. Okay, so let me tell you the formula of acceleration. Acceleration's formula is A equals V final velocity minus initial velocity over time. So these are the things you need to know. So final velocity means the velocity it has reached finally. That means after the velocity it has reached when it speeds up. And the initial velocity was the velocity that it had been using before it speeds up or slows down. And t is the time. So let me ask you a question about this. Okay, so the question says that a car was moving at 4 meters per second, then it speeds up to 8 meters per second at 2 seconds. So what is its acceleration? Using the formula I had given you before, you use A equals V F minus Vi, that is initial velocity, over time. Basically, the formula of acceleration is change in velocity over change in time. But in this lesson, we're just learning this. So first we must identify the given units, the given quantities we had gotten. So the given is the question says a car was moving at 4 meters per second. So this was the velocity it had initially. So 4 meters per second is the initial velocity. So initial velocity equals 4 meters per second. And then it speeds up to 8 meters per second. That is the final velocity. So Vf equals 8 meters per second. And it says at 2 seconds, you can know that it's the time. So the time is 2 seconds. Then required is, it says what is its acceleration. So the required is acceleration equals how much? Okay, so let's use the formula. The formula is acceleration equals final velocity minus initial velocity over time. So it says the final velocity is here, 8 meters per second. Just to wrap it up, you can just make a bracket and write only the coefficients and write their common units. So final velocity's coefficient is 8. So I write 8. And initial velocity's coefficient is 4. So it says -4. So there. And you add their common units, which is meter per second, over the time is 2 seconds. So how do you verify that meter per second over second is meter per second squared? So I'm going to tell you that 8 minus 4 is 4, and obviously, and you make a bracket and meter, sorry, I forgot 2, 4 over 2 meter per second divided by, that means over, second over 1. We obviously know that any number has the denominator of 1. So the way to divide fractions is by finding the reciprocal. So the reciprocal of second is 1 over second. So this becomes 4 over 2 is 2, and meter over 1, I mean meter times 1 is meter itself over second times second, which is meter per second square. So that means the acceleration equals A equals 2 meter per second square. There. So that's how we know the acceleration. Let me ask you another tricky questions. Okay, so it says that the man was running at the acceleration of 3 meter per second square, and it took him 6 meter per second. It took him 6 seconds to accelerate, and his initial velocity was 1.5 meter per second. So what is the final velocity? So let's collect the given ones here. So the given is the acceleration, time, and initial velocity, and the things that are given numerally is 3 meter per second square, 6 seconds, and 1.5 meter per second respectively. So what is the final velocity? So all you have to do is to derive the final velocity's formula using the acceleration's formula, which is acceleration equals So this is the formula, and if we crisscross it, you may get this. This is the acceleration times formula. So if you want to know the final velocity, all we have to do is take this to the other side, and we'll get this. So let's put the given ones into action. So it's 3 meter per second square times 6 seconds, sorry, plus 1.5 meter per second equals the final velocity. So if we use BODMAS, the first thing we have to do in this case is multiply. So 3 meter per second times 6 seconds is meter per second square times second. Second cancels the square, so we're going to get meter per second. So 3 times 6 is 18 meters per second plus 1.5 meter per second. So we'll get 19.5 meter per second. So the final velocity equals 19.5 meter per second. So guys, thanks for watching. If this video was helpful, make sure to subscribe and like the video.